To write the Lewis structure for Kf, potassium fluoride, let's first write K and then F. Potassium, that's a metal, and then fluorine, that's a nonmetal. When we have a metal and a nonmetal, we have an ionic compound. In ionic compounds, when they bond, valence electrons are transferred. So if we look at the periodic table, potassium's in group 1, it has 1 valence electron. Fluorine is in group 17, sometimes called 7a. It has 7 valence electrons. So we said in an ionic compound, the valence electrons are transferred, and they're transferred from the metal to the nonmetal. So potassium is going to transfer its 1 valence electron to the fluorine. When it does that, it's lost its electron. It's lost a negative charge. Because it's lost a negative, it now has a positive charge. The fluorine, that's gained the electron. Electrons are negative, so since it gained 1 electron, it now has a negative charge. We have a positive metal and this negative nonmetal here. They're attracted to each other and they form an ionic bond. To show that it's an ionic bond, we need to put brackets around the negative ion. You'll sometimes see brackets around the positive ion as well. The brackets are important because it shows that the electron, that valence electron from the potassium, was transferred to the fluorine. So we don't have any sharing of electrons like we would in covalent compounds. One last thing, this is what we call a formula unit. When we have ionic compounds, they're made up of a regularly repeating array of these formula units to form a crystal. This is Dr. B with the Lewis structure for Kf, potassium fluoride. Thanks for watching.